The first presentation is from somebody I've known for a very long time, one of our longest term members of the Edge AI and Vision Alliance is Synopsys. This is Gordon Cooper, Principal Product Manager for the company. And yes, I think you may have the longest title of any presentation in the program today.
I was going for the win on the longest title.
Key requirements to successfully implement generative AI in edge devices, optimize mapping to his company's enhanced NPX6 neural processing unit IP. Over to you.
All right, appreciate it. Yep. Thank you. Okay, well, welcome. I am Gordon Cooper. I've been with Synopsys about 8 years. We've got a long history of DSP at Analog Devices and at NXP. Today we're going to talk about moving generative AI to the edge. And so the interesting question is, what are the challenges to do that? What happens when you have a vision processor and an NPU and you want to add generative AI to it? So I'm making some assumptions. We deal with a lot of customers who are making their SoCs, and maybe they want to add AI, maybe they already have a vision processor they're planned, and they say, hey, is it Gen AI enabled? Now, maybe they have a specific use case. Maybe they just want to know that there's a capability they can add. So the assumption is the customer's building an AI SoC. They need to add generative AI or want to know that they can add it. And I'm making the assumption that it's power sensitive. We're talking about an edge device. Could you do it in a GPU? Sure. FPGA? Sure. But you're probably, if you care about power area and performance, you're probably looking at an NPU for the best performance for your vision processing, for your CNNs, transformers, et cetera. So we're starting there. Okay, so now why would I want to do that? Why can't I just use CNNs? Why would I maybe move to transformers and or generative AI? Well, here's just a limited use case, and I won't talk about all the other potential use cases. You can sit in your car and have it write you a 5-page paper on the fall of the Roman Empire, but I'm sure there's plenty of use cases. But what's interesting about this one is panoptic segmentation is a combination of object detection and semantic segmentation. So object detection is I'm identifying all the objects that I can see. Semantic segmentation is I'm assigning pixels. I'm grouping the pixels. Here's a group of all the pixels that are buildings. Here's all the pixels that are the road, all the pixels that are cars. So if you combine those two, you basically say this car is all the pixels for this one car, et cetera. If we run this admittedly corner case image through panoptic segmentation, which is CNN-based, it's a man ironing clothes in the back of a yellow taxi, and you see panoptic segmentation does a pretty good job of identifying most of the pixels, but it kind of struggles to figure out that that's an ironing board. It really doesn't know what to do with that. Fair enough, it may be a training issue, but it's also the difference between CNNs and transformers in terms of how well they can understand the context of an image. So if you run this through a large language model, which is based on transformers, in this case, lava, so you can actually insert an image, and you can see what it says here is, if you ask the prompt, what's unusual about this image, it's unusual to see a man ironing clothes in the back of a vehicle, basically. So fundamentally, CNNs are still excellent for object detection and for many vision use cases. What transformers, which have enabled Gen AI, give you is this extra contextual awareness. And that really has made all the difference for enabling generative AI.